This is a temperature field on a steel plate. The bottom edge is hot, the top edge is cold, and the sides are insulated. The colors show how heat flows through the metal at steady state, and the entire thing was computed with the finite element method in about a second or so using completely free software. Today we're going to build this from scratch. Alright, here is the problem in one picture. A 1 meter steel plate, bottom held at 100, top held at 0, and both sides are insulated, no heat in or out. We want to know what the temperature looks like everywhere in the middle. To solve it, we are going to use a tool called ElmerStudio. ElmerStudio is a graphical user interface, basically a desktop interface, for a finite element solver called Elmer FEM. Elmer is a serious piece of software. It's been maintained for over 20 years by CSC, the Finnish National Supercomputing Center. It's free, it's open source, and it can handle heat, fluids, structural mechanics, electromagnetics, and a lot more. The reason we used ElmerStudio on top of it is that Elmer's native interface assumes you already know what you're doing. ElmerStudio puts a relatively clean modern wrapper around it so you can learn by clicking. So two pieces of software installed separately, and it's important to note that ElmerStudio has no association with Elmer FEM, and it's just a separate software developed independently. So first, Elmer FEM itself. Go to elmerfem.org, and this is the project's main page. It's not flashy, it's a research project, not a product, but the binaries you need are right there. Right? So all you need to do is to click on Binaries tab in the top menu, and from there you can find two installation paths. For Windows, scroll down to the Windows section, download the installer, run it, click Next, Next, Finish. For Linux, specifically Ubuntu and its derivatives, the recommended path is the Elmer CSCPPA. 3 commands in a terminal, copy, paste, and basically done. So after you're done with the installation, there are 2 programs on your machine. One is Elmer Solver, the actual physics engine, and the other is Elmer Grid, the meshing tool. You won't run either of these directly. ElmerStudio will call them for you, and I'll show you how you need to initially point ElmerStudio at wherever these 2 pieces of software or these 2 programs are located on your computer. Typically, ElmerStudio can find them by default if they are in your system's path, but you have an option to specifically point ElmerStudio at wherever they are installed on your machine. Alright, so the next piece of software is ElmerStudio. The project page is at this address. You can go to the project page, and I'll put this the link to this web page in the video's description. Take a look around. There is a feature tour and some screenshots that they give you some general idea about what the project is about and what is capable of. To download, click through the GitHub basically release page. If you click on that, it will take you to the latest release. And it lists some features or some specific things that have changed for the latest release. It's not super important for us right now. The important part is at the bottom. So there are 2 main assets. One is this app image file, which is for Linux. It's a single file. You can make it executable and double click, so that will open up the software. Or you can download the .exe installer for Windows. Pick the one for your operating system, download it, and either run the installer, or on Linux just do chmod +x the app image and double click it. So in your first launch, or better to say at the beginning, ElmerStudio greets you with this welcome screen, a gallery of starter templates for the most common physics problem: heat conduction, fluid flow, structural mechanics, electrostatics. Pick one, get a working simulation input file or SIF, and that will be a great starting point. But before we click anything, we're gonna do a quick housekeeping step. Alright, so what I want you to do is to go to Edit and then click on Preferences. There you should go to External Tools option or tab and make sure that these two options, Elmer Solver and Elmer Grid, are pointing at your Elmer Solver and Elmer Grid that you installed in previous step. Typically you can click on Detect, and if Elmer Solver and Elmer Grid are in your path, ElmerStudio automatically detects them. Otherwise, you can click on Browse and go and find where the software is, the exe file is in Windows, or the executable file is in your Linux, and select those to make sure that your ElmerStudio can actually detect your Elmer Solver and Elmer Grid, because both of them are needed. Elmer Grid we need to generate the mesh, and Elmer Solver we need to run the simulation. Alright, once you're done with setting up everything we need for Elmer Solver and Elmer Grid, let's go back to our welcome screen and click the red card, which is the template for heat conduction. Once you do that, a template loads, and right away you will see a little kind of yellowish notice at the top of your SEF pane. Now, Elmer has a preferred order for the sections in an SEF file. Basically, header first, then simulation, solvers, bodies, equations, materials, and then boundary conditions. Now, the template you just loaded isn't exactly in that order, and that's fine. Elmer Solver typically doesn't require this specific order to run. ElmerStudio is just being a little polite and offering to clean it up for you. For this video, I will go with the preferred order. So I'll just click on reorder now. It really makes no functional difference, but if you like neat looking files, you can click the reorder and the sections snap into the standard order in one undoable basically step. Alright, so take a quick look at the left panel, the outline. This is a structural view of your project. Every node here corresponds to one section in the CIF file on the right side. Right, so kind of makes it easy to navigate your project input file. The header is mostly bookkeeping, including where to find the mesh file. Then you have the simulation section, what kind of simulation, steady state or transient, 2D or 3D, how many output frames, etc. You do have the solver. In this case, it's a heat equation, heat solver from Elmer, and a bunch of details about the numerical approach the software is going to adopt to solve the equation for you. You have the equation section, which after you define the equation, you have to specify what active solvers are being used for this simulation. Then you have the body. We don't really have a body yet. We haven't really imported any mesh, so this template by default assumes body number 1, but obviously there is no body yet, and we'll talk about that. You have the material section. By default, it selected a specific material. In this case is steel, which is what we want. But if you want to change the material, you click on the material section, and the material library shows up, which is a panel at the bottom. You can choose a category to basically narrow down the number of materials. ElmerStudio comes with a a set of initial materials, so you can choose from those materials. Let's, for the sake of testing, change all current material to something else. Maybe I'll change it to titanium, right? Once you select that, of course, you'll see the material properties, and it tells you what is the reference for these values. And then you can, actually, let me give myself a little bit more real estate here. And then I can go here and say, well, I'm applying this to section material 1, and I can just click apply. And immediately you can see that it changes in the CIF file. I'm going to take it back to what it was initially, and I'll just apply, and I'll keep it as is. You can explore this outline section. It includes initial condition, body force. You can actually add new sections, and everything is basically a two-way street between this outline and the CIF file. So if you click on any section, as you saw while I was doing it, it jumps into that specific section for the CIF file, and you can basically add and edit these sections either through the CIF file or use the panel that we see down here. The purpose of this video is not exactly going into details. I will go into more details about this section and how they can be done, but let's just stay focused on our own problem. And the next step, we are going to try to create the mesh we need for this simulation. Alright, now let's focus on creating the mesh for this problem. So in order to do that, I'll go to Mesh menu and I click on Generate New Mesh. Keep in mind that ElmerStudio has the capability to import mesh from different software packages. We're not gonna discuss those in this video, but if you go to Import, well, it's giving me notice that I have to save my mesh CIF file first. So I'm just gonna call it heat simulation, and then I'll save it. Right. And then you get the option to import mesh. We'll get to these later. For now, let's click on mesh and generate new mesh. By default, ElmerStudio comes with a bunch of templates. You can actually pick the template. Some of them are two-dimensional and you can extrude them, and some of them are three-dimensional. For now, for this quick simulation, we're going to click on rectangle 2D, so it's going to give us basically a rectangular mesh, and pay attention that the software jumped into generate tab. There are some panels hidden by default, so if you move this side further to left, you're actually going to see more details about the mesh generation. And remember, this is just an interface. What is running behind is mostly Elmer Grid. So if I go to Preview tab right here at the bottom, right, and click on that, I can actually rotate and see my 2D plane. Now by default, it has a dimension of 1 in the X direction. You can see the axes here, right? And in the Y direction, and then the size is 1 in each direction, right? 0 to 1, 0 to 1, and I have 10 divisions, basically 10 elements. I'm just going to leave it as is for now. It's a simple plate. There is not much we need to do. We can just save it as is. This is all we need. So to do that, I can click on save.grd, which is basically the default file type for Elmer Grid. So I'm going to click on save, and I'll go to wherever my CIF file was. This is kind of important. You have to save it in the same folder that your CIF input file was located. So save it there. When you save it, by default, it does not really come to your simulation. So you actually have to, let me move this back to where it was. I'm going to go back to mesh. You actually have to go to File, Import Mesh, right? And then use the import file. to import the mesh, and this is the mesh I just created. So if I click on that and click on open, and then you can maybe vaguely see my plate. It has a very dark boundary color, so it might be a little difficult to see. You can go to mesh. You can see that I'm only showing the boundaries. If you click on show wireframe, you can actually see the whole plate. There are a couple other things you can do there. You can also turn on the show measurement grid, so you can actually see the dimension. And then let me give it a better view, so it's a 1 by 1. I can turn it off. You can also add the origin axis, and you can see it's sitting basically on the corner, like the edge is on the corner. These are the things that become more important. They become more important when your mesh is more complicated. There are other options here too, but the most important one I would say is the mesh quality. In this case, we have pretty good quality mesh. Obviously, it's a simple plate. And you can also get mesh statistics, which tells you the number of elements and the number of boundary elements, and also the general information about your mesh. Alright, so now we have the mesh, and as you can see, it says mesh here. One thing I want to mention is that you can actually go and open the directory of the project, right? Every file, including your zip file and your mesh file, using open project in the file manager option right there under the run menu. Now this works only if you actually set it up. So yours might be grayed out. If you go to tools and go to configure user tools, there you can actually set up what kind of tool you need. You can detect your terminal. Some people are more comfortable with terminal, especially power users. You can detect what kind of explorer, file explorer you use. I'm using Ubuntu, so it's using this option. And you can also have your text editor, whatever that text editor is. If you're more familiar with Gmesh and you have a CAD software, you can also link them to your project folder. So once that's set up for the file explorer, if you click on the file explorer, it actually takes you to the project folder. If you set up the terminal, in my case, it's a default Linux terminal. So if I click on that, it's going to open the terminal in my project folder. All right, so that's that. Now I have the mesh. The most important part in my simulation is, remember, I have to set up the boundary condition. But as of now, if I click on a boundary of this plate, right, you can see that the whole thing is just one boundary. When I generated the mesh, there were options to create these boundaries, but I wanted to show you how you can do it when you bring the mesh to your simulation. So as of now, there is only one boundary. If you left click on the boundary, you can actually select the boundary. If you hold down Control and left click, then it gets deselected. So let's see how we can actually split this or get 4 separate boundaries. There are a lot of options, so I'm going to select the boundary again. Right? I'm going to click on it, and then I will go to mesh, and there I will click I will go to boundaries, bodies and boundaries. There are a lot of options there for cleaning up the mesh and doing different operations on a mesh file. For this simple simulation, we simply just click on split boundary by feature angle. And you can see there is only one boundary right now, which is the whole perimeter. We can leave the default. This basically splits the boundary based on the angle between the lines. And by default, it starts the numbering of the boundaries from 2, because 1 is what we have. So I'm going to click on OK, and then it's asking you that if you want to replace, because you have an option to keep the old mesh, which is useful. Sometimes you don't want to override your mesh and you want to create a new copy, but I will just click on replace. Once you do that, if I click on any edge, you can see that now I have 4 separate boundaries. I'm basically just left clicking on each boundary. I'm going to save my file. Right? save or Control S, either one works. So now I actually have a plate with 4 separate boundaries, and I'm ready to apply the boundary condition to this mesh before I run my finite element simulation. Alright, so let's go back to our problem setup. Now we have the mesh, we have the plate. Let's take a look at the boundary conditions. Remember, the top part was supposed to be set at 0. I called it boundary condition 3, but we'll see what is the boundary number there. But pay attention to the coordinate system x and y. So the top part is set at 0, the bottom is at 100 degrees, and the left and right both are basically left alone by default. They're going to be insulated boundaries. So I'm going to go back to my setup there. You can just click on Z and get the same direction. Just pay attention to XY axis at the bottom, the direction of those axes. And again, remember the top part was 0, so I'm going to select the top boundary, and you can see here that is by default is selected. If you right click on that on the outline, you can add field, and let me make this a little bigger, and then I will set the temperature. I need to set the temperature. I select the temperature. Once I do that, it shows up here, and then we just have to put 0 and press enter. Once you do that, you can see even at the bottom now it's selected and it's set. All right, so we need one more boundary condition at least. So I'm going to right click on the boundaries on the outline, right there. I'm going to right click on that and I select add boundary condition. Pay attention so you don't mess things up here. You have to click on boundary condition 2 now. You can see a warning there that says no boundaries. So ElmerStudio is nice enough to let you know that something is missing there. So click on that. You can see also in zip file that the boundary condition is added now. I'll do the same thing, right? Or maybe let's just click the select the boundary first. So I'm going to go to problem setup. Remember, we're selecting the bottom part now, so that would be 100. I'm going to go back there. I'm going to select this boundary now, and you can see now it's selected, and it's 1. I'm going to right click on that. I'm going to assign, I'm going to add fields. I need to set the temperature there, and then I'll put the temperature 100 degrees, and I press enter. That's important because when you press enter, actually adds the number for you. I'm going to save my simulation. We are almost ready to run our simulation. All right, so let's run it. All right, at this point, everything is set up. We'll go to run, and you can click on run ElmerSolver or press F5, or you can just come here and click on this green button to run ElmerSolver. If I run that, I'm gonna get this warning that's basically trying to tell me that, by the way, you have 2 boundary conditions that are not assigned, which is fine because as it said here, they will use natural zero flux boundary conditions for these, and that's what I want. So I'll just say run anyway. If you set things up properly and your ElmerStudio can identify ElmerSolver, you are going to see the output. ElmerSolver basically running the simulation. This is a simple simulation, so it's pretty quick, and then you can even get the convergence plot. Not too fancy, but it tells you basically the relative change and the equations that were solved. We don't want to keep them there. You can go to view and basically uncheck those boxes, and then as you saw, it immediately jumped into the results section tab there. It is already on temperature since there is only one field I'm calculating. We can change the color range. Yours might by default be on this setting, but you can change it to jet just to get a better sense of how the temperature is distributed, and you can just move it around and look at it from different angles. But that's basically it.